What is up, amigos? Today we're looking at windscreen wiper aerodynamics, and they may not seem like they're very important because they're so small, but the aerodynamics of windscreen wipers are very complex for a few reasons. One, they move with operation, so they may be at one angle at one point in time, but then they change over the operation. Two, they have direct and indirect effects, so that also affects the entire car's aerodynamics to some extent. And three, over the years, their shapes have changed quite a lot, and also ways to hide them have changed as well. So quickly, let's get this out of the way. First of all, when we have the windscreen wipers that are not in operation, so we have them, let's say here, they're poking out, and to begin with, they used to just have the hood like this, and then the air would come along and then hit these windscreen wipers, and that'd be a permanent fixture on the car that would always see the flow. That results in more drag, a little bit, and then also flow separation and some potential problems for the windscreen itself. But, cleverly, people got the idea of to raise the hood up a little bit and then hide them underneath. So you know how with the hood we usually get it stopping here. Then we have this region here where we actually have flow coming along, and then we have a separation zone here. We hide the windscreen wipers in there so that when they're not in operation, they're effectively out of the flow. They're not really affecting the flow of the car at all. But what about when we have them in operation? So let's say now we have the window itself, we're looking down on the window, the windscreen, and let's say the windscreen wiper is located here, that's where it's attached. And through operation, it can be at any angle up here like this. So as the angle increases, the aerodynamics actually changes. So let's talk about this angle where it's completely flat first. So it's just popped out of the hood here, and we can see it. So let's say it's about here. The flow comes here, and because this is effectively a bluff body, we get flow separation, and we get this separation zone around here. So that means we just have a dead wake region, which isn't good for aerodynamics. But as we increase the angle, so the blade gets steeper and steeper, it then gets to a point here, let's say, and now we start to get a vortex forming around. And that can be sucked over the roof. So it'll come up here and sucked over the roof, and that can change the roof aerodynamics as well. And if you don't know about roof aerodynamics, check out this video here where we covered that. And I'll also mention that with this region here, regardless of whether we have the windscreen wiper here or not, we do need to have some sort of venting flow here. This is to do with the cooling flow. So we take advantage of that with this hood ornament here. So that is the reason why the aerodynamics changes with the location of the windscreen wiper. And we have secondary and direct effects. So the direct effect is obviously we have this vortex, but secondary effects are that this vortex can get sucked over the roof, and then it changes the aerodynamics of the roof section and then the flow separation pattern behind there. What about the windscreen wiper shape? So to begin with, like if you look at cars from 20 years ago, the windscreen wipers were very bulky. Like you'd have like the bar holding it. This is like a cross-sectional view. Then you have like some sort of springs coming down, and then it would hold the actual windscreen wiper itself. And if you fast forward to today, now they are much more streamlined. So you might still have that same kind of profile, but then you have the wiper sort of just poking out here. So all the springs and everything are hidden in here. And you can get different profiles as well. So you can even get like it sort of coming up like this, which we'll get into in a second. But let's talk about this shape here first. Now this is a very unaerodynamic shape. What happens is the flow comes in and it crashes into this, and what we have is usually very high pressure here, low pressure here because we have flow separation. That results in a lot of drag, but also because the flow comes up and then around, we get a drop in pressure up here. So we actually get lift being produced, and that's why windscreen wipers can fly off of the windscreen at high speeds. If you go to like old cars, sometimes that does happen. Now, by converting the windscreen wiper into something like this, where we get a separation point here, we can actually get rid of this low pressure zone here, which means that we don't get as much lift. That means that this windscreen wiper can suck down to the windshield as well. But even without this point here, this is still much more aerodynamic than this geometry here, because we have the flow coming in, and sure, we do get quite high pressure here, but it's only a very small region compared to what we had here. So the drag on this windscreen wiper configuration is lower than this traditional one. So that is the windscreen wiper aerodynamics in a nutshell and how it changes with its operation. So if you like this video, make sure to like it. If you like this, click the subscribe button. And if you like what I went through in this video, check out a course by JKF where they go into motorsport aerodynamics, like how we're talking about now. They talk about it for motorsport aerodynamics in even more detail and through theory and practice. You can find that course and link in the description. And I'll see you in the video. Peace out, amigos.